Hi and welcome to this video on surds, GCSE level maths made easy. Now surds are irrational numbers left in root form. Square roots and cube roots give rise to the surds or irrational numbers. The exception to the rule is square numbers. So if we have the square root of 4, that's a whole number. Square root of 9, that's a whole number. And that's not a surd. It's not an irrational number. An irrational number is a number that, say, square root of 2 is an irrational number. It's 1.41213. It's an irrational because it carries on without repeating or a number recurring. So it's not 1.44444 or 1.412412. These numbers are non-repeating, carry on and on and on. Square root of 9, 9's a square number, equals 3, which is a whole number, so it's not a surd. So surds are used where an exact answer is required. We don't want this long, non-ending number. So when we want an exact answer, or you're asked for an exact answer in the exam, you use a square root like this, or a surd. Multiplication law regarding surds: square root of a multiplied by square root of b equals square root of a multiplied by b. So a multiplied by b and the square root of the product equals the separate square roots. Using this law, then we can use this law to write some surds in terms of the smaller surds. So we can break up this large surd like square root of 12 into two factors of 12, which are 3 and 4. So square root of 12 is square root of 3 multiplied by square root of 4. Now note that this square root of 4 is a square number, gives us 2. So we can get rid of this square root of 4, can simplify and put 2 instead of that. So this becomes 2 square root of 3. So square root of 12 equals 2 square root of 3, simplification. So when we're simplifying surds, the technique is to use two numbers, or find two numbers that multiply together to give us this number underneath the square root. And if one of the numbers is a square number, then we can simplify that further to use the whole number, and we can rewrite that as the whole number multiplied by the square number, which is smaller than the original number, so it's simplified. So here square root of 18 equals the square root of 2 multiplied by the square root of 9. Square root of 9 is a square number, which gives us 3. So we can get rid of this square root of 9, cancel that out, and write 3 instead. So square root of 18 equals 3 multiplied by square root of 2. Now when we're writing 3 square root of 2, we take that as 3 multiplied by square root of 2, even though we haven't written the multiplication sign. Here we're going to use some of the rules of multiplication. So square root of 4, we can break that down using our rule into square root of 2 times square root of 2. Two roots which are the same multiplied together give us that root, so it gives that number underneath the root rather. So square root of 2 times square root of 2 is 2. So algebraically writing that, square root of b multiplied by square root of b equals b. Square root of 2 squared gives us 2. So writing that as algebraic form gives us square root of b squared equals b. Square root of 4, which is 2 squared, equals 2. Okay, let's go through some examples. The more you go through these examples, the more you learn about surds. So let's just go through these one by one. Square root of 5 times square root of 4, that equals square root of 4 times square root of 5 times 4 rather, which is the square root of 20. Square root of 16 multiplied by square root of 3. Square root of 16, that's a square number, so that's 4. So that becomes 4 square root of 3. So we can rewrite this as 4 square root of 3. Square root of 8, that's square root of 4 multiplied by square root of 2. Square root of 4 is 2 So we can rewrite that as 2 square root of 2. Here we've got 3 square root of 2 multiplied by 5 square root of 2. What we do in this case is where we've got a number and a square root multiplied by a number and a square root. We multiply the numbers, so 3 times 5 is 15. Then multiply the square root, so square root of 2 times square root of 2 using this rule is 2. So this becomes 15 times 2, which is 30. Same here. 2 times 4 is 8. Square root of 3 times square root of 5, square root of 15. Similarly here, square root of 2 times square root of 12. Here we can multiply together first. So this becomes square root of 24. Then simplify this because there's a square number we can use, which is square root of 4 times square root of 6. Square root of 4 becomes 2, and then square root of 6. Simplify. This is not simplified because the number is not smaller than 12 or not 2. However, this is simplified because its number is less than square root of 12. Square root of 6 less than square root of 12. Simplified. Okay, if we're given square roots in brackets and we have to multiply them, so here we've got square root of 2 multiplied by 2 square root 3. Think of it as a 1 next to the square root of 2 multiplied by 2 square root of 3. So we multiply the 1 and the 2, gives us 2. Multiply with the square root of 2, multiply by square root of 3 gives us square root of 6. Okay, so do it one at a time. However, if we're given this, a plus square root of b squared, do not, I repeat, do not, a squared plus square root of b squared. This is 2 brackets, a plus square root of b multiplied by a square root of b, and then we multiply out the brackets, which equals a squared plus 2ab squared b plus b. Here I've given an example of multiplying out one term with 2 terms. So when we multiply this first term by this square root of 2, we get this up to here. When we multiply this term by the minus 1, we get this. Then square root of 2, minus 2 square root of 3 multiplied by square root of 2 is minus 2 square root of 6. And here we're multiplying the minus 1 by this term, so we reverse the sign to give us plus 2 square root of 3. Again here, multiply out this term by this term, so multiply out the brackets, or these 2 terms rather. So square root of 2, when we multiply out, we get this. When we simplify, and then don't forget, in this multiplication, square root of 2 multiplied by 2 square root of 2 gives us 2, and then square root of 2, which is 4. So 2 square root of 6 plus 4. So just be careful with that little thing there. This 2 square root of 2 multiplied by square root of 2. Law for division of surds, square root of a divided by square root of b equals square root of a divided by b. Best understood if we work through it. So square root of 8 divided by square root of 2 equals square root of 8 divided by 2. 8 divided by 2 is 4. So this becomes square root of 4, which is 2. Here we've got square root of 15 divided by square root of 5. Using this division law, this is square root of 15 divided by 5. 15 divided by 5 is 3, so square root of 3. This becomes 2 divided by, this becomes 8 divided by 2, which is 4, as in multiplication, like we did there. Then do the roots next. Square root of 6 divided by square root of 3, square root of 2. Addition. Now be very careful here because you can't do square root of a plus square root of b. It doesn't work as this equals square root of a plus b, okay? Don't do that. The only way we can add these is if the numbers under the roots are the same. And the way I like to think about it is, I like to say 4 lots of square root 7 plus 2 lots square root of 7 equals 6 lots of square root 7. Subtraction, 8 lots of square root 3 minus 5 lots of square root 3 equals 3 lots of square root 3. If there's an addition you can simplify, like as in this one, you can write square root of 27 as square root of 9, square root of 3. You can write square root of 12 as square root of 4, square root of 3. Then you can write this in this form by square root of 9 equals 3, square root of 4 equals 2. 3 lots of square root of 3 plus 2 lots of square root of 3 equals 5 lots of square root of 3. Okay, here again we've simplified, then we've summed the terms together. Here we can take the 3 out, we can factor out the 3 and put the plus the square root of 5 plus square root of 7 in brackets. If we multiply out the brackets, you can see we get 3 square root of 5 here plus 3 square root of 7. So if we've got the same number, when we're adding, we can factor out that number. Okay, finally, we're going to go over rationalizing the denominator. Now, if we've got this division where we're dividing by a square root, remember the square root is an irrational number. It's 1.41213, so on, so on, so on. Quite a large number, not an exact number. And we need an exact answer, so as mathematicians, we need to get rid of this square root of 2 under this division sign, as get rid of square root of 2 as the denominator. So we need to rationalize the denominator, and we do this in this fashion. If we have a square root on the bottom, we multiply by having the numerator as the same as the denominator. So write it in this form, multiply together, so it's like multiplying by 1. So 1 multiplied by square root of 2 is square root of 2. Square root of 2 times square root of 2 is 2, so we've got rid of that square root on the bottom. We've rationalized the denominator. Here, if we have 1 minus square root of 2, we reverse the sign under the denominator, have the numerator the same, so that equals 1. And then we're multiplying this by 1, so this remains the same. But when we multiply out, we get 1 minus square root of 2 minus 2 plus square root of 2. This is the denominator, this term multiplied by these two terms multiplied by these two terms, so we put brackets around them. These two square roots cancel each other out, so we've rationalized the denominator. We get 1 minus 2 as our new denominator, which is minus 1. And when we multiply out these two terms with these two terms, we get this, which is 3 plus 3 square root of 2. If we want to rewrite this, distribute the minus, and we get minus 3. When we factor out the 3, minus 3 plus, in brackets, 1 plus 3 square root of 2 in brackets. Here we've gone through some rationalizing the denominator, but slightly difficult, or slightly more difficult. This is a tricky one if you're ever given like this. Square root of 3 minus 1 all under brackets. This is essentially just square root of 2. So when we're rationalizing, this is how we represent the 1 square root of 2 over square root of 2. So 2 square root of 2 multiplied by square root of 2 is 4. And square root of 2 times square root of 2 is 2. Here it's like normal. We're just going to reverse this sign. Put that as the denominator. To make this equal 1, we have the same as the denominator as the numerator. Then multiply those two together. We get 2 square root of 6 minus 2 square root of 3. And this essentially, the square roots cancel each other out when we multiply out the denominators. So we've rationalized the denominator. So 2 plus minus 1 is 1. and this top we factor out the 2, and we get 2 square root of 6 minus square root of 3 in brackets. Similarly here, reverse the sign, put that as the denominator, put the same as the numerator to make this effectively equal 1, and multiply to rationalize the denominator. This denominator becomes 9. Here we get, factor out this 12, so we get 12, 4 minus square root of 7. Then, because we've got one term on top, one term on bottom, we can cancel the 12 with the 9, and we get 4 over 3. 4 over 3, and in brackets, 4 minus square root of 7.